This routine calculates the group sample sizes necessary, typically at least 30, to achieve a specified interval width of the differences between two independent proportions. Suppose you have two populations from which binary responses will be recorded. The probability or risk of obtaining the event of interest is population 1 is P1, and in population 2 is P2. The corresponding failure proportions are given by Q1 equals 1 minus P1 and Q2 equals 1 minus P2. The formula for the confidence interval for the difference between two population proportions is P hat 1 minus P hat 2 plus or minus Z times the square root of P hat 1 times 1 minus P hat 1 divided by N1 plus P hat 2 times 1 minus P hat 2 divided by N2, where P hat 1 and N1 are the sample proportions and sample size for the first sample, and P hat 2 and N2 are the sample proportions and sample size of the second sample. The z-value is the appropriate value for the standard normal distribution for your desired confidence level. To calculate a confidence interval for the difference between two population proportions, do the following. 1. Determine the confidence level and find the appropriate z-value. 2. Find the sample proportion. For p hat 1, you do it by taking the total number for the sample that are in the category of interest, and then you divide that by the sample size n1. To find p hat 2, you do the same thing, but instead of dividing by n1, you divide by n2. 3. You have to take the difference between the sample proportions, which is p hat 1 minus p hat 2. To calculate a confidence interval for the difference between two population proportions, do the following continued. 4. Find the values for the following. P hat 1 times 1 minus p hat 1 and divide that by n1. P hat 2 times 1 minus p hat 2 and divide that by n2. Add these two results together and take the square root. 5. Multiply the z-score that we found in step 1 by the results from step 4. This step gives you the margin of error. To calculate a confidence interval for the difference between two population proportions, do the following continued. 6. Calculate upper and lower confidence intervals. The upper end of the confidence interval is p hat 1 minus p hat 2 plus the margin of error that we got from step 5. The lower end of the confidence interval is p hat 1 minus p hat 2 minus the margin of error that we got from step 5.
Now that we've discussed what it means to estimate the difference between two binomial distributions, let's move on to our example of how to apply this estimation to a real-world example. Suppose you work for the Staples Center and you want to estimate with 95% confidence the difference between the percentage of all females who have ever gone to see Beyonce in concert and the percentage of all males who have gone to see Beyonce in order to determine how you should market your entertainment offer. The first thing we're going to need to do is determine the confidence level and find the appropriate z-value for our selected confidence level. Because we want a 95% confidence level, our z-value is going to be 1.96, which is found on the z-tables. Our next step is going to be to find the sample proportion. First, we'll need to find p hat 1 for the first sample by taking the total number from the first sample that are in the category of interest, which in this case will be how many women have seen Beyonce in concert. After we find that value, we'll divide that by the sample size, or n1. Similarly, we'll find p hat 2 for the second sample and repeat. Now suppose you're given two different samples. Sample 1 contains 100 females that include 57 females who have seen Beyonce. This will give you your p hat 1 value of 57 divided by 100, or 0.57. Your second sample is 100 males, 25 of which who have seen Beyonce in concert. This gives you your p hat 2 of 25 divided by 100, or 0.25. Now that we have these two values, we can take the difference between the two sample proportions, or p hat 1 minus p hat 2. The difference between our sample proportions ends up being 0.57, which is the female ratio, subtracted by 0.25, which is the male ratio, which gives us a 0.32. Now that we have found the difference between our sample proportions, we need to find the components under the square root in our formula from earlier as explained in the following slide. Since we have all the variables we need, all that is left to do is plug in our values. The following slide demonstrates the process we used to find the value for second half of the formula to determine the confidence interval. We start with our p hat 1 and then our p hat 2 values. Once we have divided both values by the respective sample size of 100, we take the square root of the sum value. Now we need to multiply our z value from the value that we acquired from our previous step. This will give us our margin of error. Once we've multiplied our z value by our previous value, we come out with a margin of error rounded to about 13%, which is demonstrated in our next slide. Now we need to use the difference between the sample proportions we found earlier to calculate the upper and lower ends of our confidence intervals. The difference between our sample proportions we found earlier was 0.32 and the margin of error we just found was 0.13, which makes our confidence interval 0.32 plus or minus 0.13. This makes our lower end of our CI 0.19 or 19% and our upper end CI 0.45 or 45%. This means the difference in these percentages is somewhere between 19% and 45% based on our sample.